Day 12. Beautiful, beautiful. That's amazing. Here it is. We are going to update the thumbnail. No, it's not made for kids. Awesome. I think that's everything I wanted. I haven't seen this. Nim, I bet it looks like back in 10. That's pretty dope. All right. There it is. Awesome. We are alive. Beautiful. Let's go over to admit of code. Day 12. Let's do it. I can't listen to lo-fi right now. There we go. For example, constant breadth equals, sure. Start top of goes near the middle. You could be starting to move down or right, but eventually towards at the bottom. Maybe with our symbols indicate the path that exists square moving up, down, left, right, the location that should get the best signal. Still capital E. And dot marks the unvisited squares. This path reaches the goal in 31 steps, the fewest possible. What is the fewest possible? Few steps required to move from the current position to the location that we should get the best signal. Oh my god. Now I need to implement a path finding algorithm. Damn. Into a grid. The elevation of each square of the grid is given the single lowercase letter where A is the lowest elevation, B is the next lowest, and so on and so forth. Z also includes the height maximum line S and the location that you should get the best signal, capital E. Your current position, capital S, has an elevation A, and the location that should get the best signal has capital E, has a signal, capital E, has elevation Z. Okay. You'd like to reach E, but to save your energy, you should do it in the fewest steps as possible. During each step, you can move exactly one square up, one square down, one square left or right. To avoid needing to get out our climbing gear, the elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you should oh my god, you could step to elevation N, but not to elevation O. This also means that the elevation of the destination square can be much lower than the elevation of your current square. This also means the elevation of the destination square can be much lower than the elevation of current square. Destination. Oh, so you can most one higher. So you can go down as much as needed. Wow. So you go down, you go left, you go down, you go left, you go down, you go left, you go right, 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 up, up, left, left, right, down, E. Oh, down, down, up, 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 left, 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 down, down, down. So it's spiraled into E. Okay. Damn. Wow. What the fuck? Capital S. That's a lot of S's. What the fuck? Hmm. Wait. Why are there so many? Where's the capital S? Oh, right. There used to be. Oh, right here. That's the capital S. And we're looking for capital E, which is right there. Oh, so this is like a topological. That's pretty dope, actually. Holy shit. Um, wow. Right off the bat, I have no idea exactly how to solve this right now, simply because I don't know. I think I wrote a pathfinding algorithm A star a while ago. Like I think Daniel Schiffman has a great video. Schiffman A star pathfinding, right? A star pathfinding algorithm. See? Um, I don't remember how to implement that. So it seems like I didn't know this, but it seems like every single day of like advent of code is supposed to get more and more difficult than the previous one, correct? I will also confirm on Twitch that nobody is watching. Channel bars. All right, that's just me. That's me. Cool. Okay, so so at every single point there are multiple ways to go. How do we know we're gonna get closest to E by going that route? I think A star is probably okay, A star implement, implementation. Implementation. Okay, let's take a look. So 2D grid of several obstacles. Da, 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 da. Yep. In Informing speaking, A star algorithms, unlike the other traversal techniques, it has brains, which means it can really, but there's a really smart algorithm that separates it from the other conventional algorithms. The fact is clear. Da 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 da. Explanation: consider square grid has many obstacles. Starting cell and target cell. We want to be able to easily. Yeah, I think this is the perfect algorithm to implement for this solution. Yeah. Yes, and initialize the open list, initialize the closed list. For the starting node on the open list, you can leave it if it's at 0. While the open list is not empty, find the node with the least F on the open list, call it queue, pop queue off the open list, generate queues 8 successor, and set their branch to queue for each successor. If successor is a goal, stop search, else compute both G and H for successor equal. Q.G successor for successor. If a node in which position successor open list, right? It's not quite this simple because the possible combinations for the next move change based on which element we go to. So hmm, I mean, we could brute force this for sure. I don't know. I don't like spending time on brute force solutions, but it's not just like a normal pathfinding solution either because of the change of the change of the topological moves that we can make per square, right? So, hmm. So for each one of those places, we can figure out um, each place we can figure out where we can go. Dijkstra's algorithm. That is another possibility. Dijkstra's algorithm. Oh, Nim definitely had a had a util library to do the Dijkstra's algorithm. Gaussian graph, which means there's a specific world level. It was conceived by computer scientists. There are in-system many variants. Original Photoshop. Most common variants in the node. The source node. And the short also. The algorithm finds the shortest path between a node and every other. It can also be used to finding the shortest path from a single node to a single destination node by stopping the algorithm once a destination node has been determined. For example, if the node of the graph represents cities and the edge path costs represent driving distance between the pairs of cities connected by the node. Da, 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 da. Shortest way to travel. Here. Now, would I want to represent this as a graph structure? Maybe. It could be imagined as a graph structure for sure. Each each location being a node and being connected to all the places that are possible to travel to from there. Hmm. And then you throw on something like, I mean, normally I would try to understand this, but npm trace. I like that idea of representing it as da 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 da. Oh, dot add node. Oh yeah, I like that. B1. What is B1? What is this value? CD D4. Path from A to D, A B C D. New graph route dot add. Huh. What is the number? That's what I want to know. node, neighbor, cost number. Cost number. Hmm. It's possible to pass a constructor a deep map that allows using numbers as keys for the nodes. Okay, so yeah, I could get away with. Hmm. The cost is going to be one for every single one of those things. 6 years ago. God damn. That's crazy. That shit is crazy. I mean, it seemed pretty simple, so I don't know if it still works. Oh, 7 days ago. Yeah, I'm not sure if it still works with the latest node. That's a lot of dependencies. I mean, we could certainly try it. All right. Well, let's do npm init dash. All right, fine. Yep, that's fine. That's fine. That's fine. No, that's fine. Yes, but package.json, the entry point needs to change from script. This can go away. Watch node mon. I want to take that as a input, but whatever. I'm just gonna pass it in like so, and then I want to do npmi. All right, let's test it out. npm on watch, by the way. Cool. What I want to do is const graph equals require node digstra. Okay, and then we can do, let's take this example, see if it still works. Wow, it does still work. Okay. I mean, that makes our job a lot easier. Yeah, it does. Um, yeah, I don't really have to implement this. Just go in 31 steps, the fewest possible. Hmm. All right. So I want to check neighbors for every single one, and I want to see where it can possibly go. And then I think I'm going to just save um, the X and Y position for each one of them as the key. And yeah, that's it. So if I was to go cost, routes, or um, not routes, but areas, something like that. And we want to split on every single one. And well, dot map row dot split. And then I can go console.log areas. There you go. It's pretty accurate. Oh, yep, that's right. SAB, whatever. Okay. uh, for areas, I call this grid. Grid dot for each row. Row dot for each cell I. If write down, it's whatever. I want to go. All right, chill. I want to get the neighbors of this cell. Up, down, left, right. What is it saying? Right. Row plus one. Down. This. You can go from A to B. You can go from B to A. Yeah, I think they need to exist on both sides. Okay, fine. And get char code. Calculate. Sure. Char code. I do want to get next car code. No. No. Uh, Cost char equals cell equals E. Then it's gonna be, oh sorry, it's gonna be, if it's S, then it's gonna be A. Otherwise, cell equals E. It's gonna be Z. Otherwise, it's gonna be cell. That's right. Cool. So now I can go. I can say const start. No, it's fine. Const end. I mean, that wasn't completely wrong. I did like that. But okay, let's see how I want to do this first. I did like the up and down. But I need to go all directions. Girl, I hate doing this grid stuff sometimes. Okay. If has upper neighbor and no and can go up, then I want to say char no route dot add node. It's gonna be I j, but it's gonna be I j like that, and it's going to be two. Yep, pretty much exactly right. I minus one can go up. Yep. J. What? Why? Why is that not okay? Property assignment expected. Oh. What? Oh. Mhm. Yep. If cool. Love that. Function. If ij, if I is greater than 0. Yep, that's pretty accurate. What's J for? Uh, row, rows length function, rows length minus 1. Function has left over. function. I do have grid available though, so yeah, I'm not gonna bother. Grid dot length, grid dot length. Don't need this now. Okay. So I J and J, and then I just need to go, can go up, can go down, can go down. So this is gonna be function can go up, and this is gonna be cell, and then upper cell. Oh shit, this is really interesting. Function can move cell, next cell. Cell can. I should call this cell valve. Make cell valve. Damn. And we can go if cell dot code at 0 is less than, no. We just want to go on the terms. Val dot next cell val dot char code at 0 minus cell val at dot char code at. If that is less than or equal to 1, then we can move. Yep. And that's just going to be it. Can move. It's going to be car. And then, oops. Can move car. Great I plus 1. Remember, yep, that's correct. Can go left. Can move car grid I j minus 1. That's left. Yep. And move j plus 1. That's accurate. Yep. I like that. I like that. All right. And then for each we have that. And there's only one problem because we want to get function get cell val, and then we can go cell char, and then you can basically say this return, and then we could do get cell val. Next cell cell And instead of char, we can just pass in cell. Wonderful. Nice. Cell is not defined. It certainly is. Right here. Oh, I could just say cell. There you go. Yep. And I want to visualize this graph that we have created. How can I do that? Console.log graph. Graph dot. I don't want these anymore. Oh, graph, route. There it is. And can I do route dot, what was it? Let's take a look. Oops, was that not? Oh, I guess I didn't share my question. Anyways, same thing. And what I want to do is node not that. Yep, we could just do this. So we just want to keep the start. Const start equals grid dot find. No. No, I don't want to do that. Const start equals sure. Const end equals that is not at equal grid dot find row dot includes e 0 dot find row dot includes e dot find cell equals e console.log and what happened? Route dot. Oh, that's fine right now. Right. Is it not? Just find first. Oh. Find index. Index? All right, this is, so it's just gonna have to be grid. What is this, grid? No, it's stupid. Um, this is gonna be a little stupid. Wait, what? Cool. I2J5. Sure. S S S. There you go. So now I just need to go here. Route dot path, I think. Path start end. There we go. Path. There we go. Dot length. 32 minus 1, I guess. I think that's good enough for me. Length minus 1. Alright. So, yep. Copy that. Skirt, 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 skirt. 528. We can certainly test that out. 528. I'm about it. That was not that bad, actually. Alright. 12b.js. Copy, paste, save. Alright, this time we're going with 12b.js. Let's see, part 2. Hackerman. Hey, how's it going? Are you still watching? Oh, hey. Shivan. See? Thanks, man. Thanks, man. Working on part 2 now. Let's take a look. As you can walk up the hill, you suspect that elves will want to turn this into a hiking trail. The beginning isn't very scenic, though. Perhaps you can find a better starting point to maximize exercise while hiking. The trail you should start as low as possible, elevation A. The goal is still squared marked E, however, the trail should still be direct, taking the few steps to reach the goal. So you'll need to find the shortest path from any square to elevation A to the square marked E. Again, consider the example from above. Now there's 6 choices for the starting position. 5 marked A plus the square marked S. That counts as being in elevation A. If you start at the bottom left square, you to go most quickly. This path uses the goal in only 29 steps. What are the fewest steps required to move from any square to the elevation location that should give the best signal? This is required to move starting from the square with the elevation to A. There's a few steps required to move starting from the square with the elevation to the location. Starting from the square location that should give a signal. I mean, however, the trail should be direct. In the future, I have to find the shortest path from any square elevation to A marked E. So is the thing that we can only go to connected A's, or we can go to any A? Well, let's take a look. A. Huh, interesting. Yeah. Not sure if we can go to any A. Thanks, man. Do you want a hint? I mean, are you looking at how I did it? I guess. Kind of. I don't know if I would consider it cheating. I don't know. I did use a little bit of a library. But I just didn't want to waste time implementing this. It's not that complex to implement this, but it is a pain in the ass. So we can do. So can we only go to connected A's, or we can go to any A? Elevation A. Of course, those square. Now there's 6 choices between position. 6 choices. 1, 2, 3, 4, 5. Is there an A that is unconnected? Oh, and the S by itself. Expect the L's will want to turn into a hiking trail. The beginning isn't very scenic though. Perhaps you can find a better starting point. To access the trail should start as low as possible elevation A. The goal is still squared on B. However, the trail should be direct, taking the fewest steps to reach its goal. So you'll need to find the shortest path from any square at elevation. Any square. Okay. So it doesn't have to be connected. So let's go ahead. That's pretty easy because we've already created the graph. So instead of finding start, we can say const possible starts equals an array, and this could be from. This is going to be pretty easy. So you can basically say grid dot possible start. So any point that is an A or an E, A or a capital S can go in this. So grid of grid. Let me think. Yeah, I could just put it as part of this, honestly. If cell equals A, or set equals S, possible starts a push, I, J, beautiful. And then we could just say possible const Uh, best starting point equal follows or reduce best. Ooh, I do like this way of doing it. Current distance dot arm length. Best distance equals best dot end dot length dot minus one. Turn current distance. Okay. So it's saying current distance equals route dot path current end length minus one. We don't need to do that. Oops. And then the best distance is sure, current distance. I mean, it is reduced, so we can start with 0. I don't know. Huh, I guess we don't need to pass it if we're calculating best distance every single time. Current distance is less than best distance, current best. I mean, I could just, if I keep track of it, I could just keep math.infinity. Or is it just infinity, actually? Infinity. There you go. And then we don't have to calculate it every time. We can just keep track of it. Best, best. If it's less than best, then we do current, otherwise we do best starting point. Oh, I see. He was keeping track of the best starting point. That's why. I see, I see. But we only need to do it if there's actually a best. So if we can do if, no, best, then we just want to return the current. So right here, return current distance, like so. And then we have the best starting point. And then we want what? What are the few steps required? Oh. Actually, if we just needed that, I had it right. Infinity. And then we only need to keep the best distance. Yep. We don't need this. Current distance. We don't need this. If current distance is less than best distance, current best distance. Best distance console.log best distance minus 1. There you go, and we can test it real quick with this. Save. npm run watch, I think. Not a number, that's exactly what I expected. Current distance equals route dot path current end dot length return current distance minus best distance current, otherwise it's best distance. I'll call this BD. Not a number. Why is that? Oh. Start. Don't need that anymore. Possible starts. We'll add to this when looping over grid. Okay. BD. What is BD? Oh. Oh, current distance. There you go. 30, apparently, which is correct because we just want to do -1, 29. Beautiful. You can go here, copy this. Da-dum, ba-dum, ba-dum. What's the problem? Oh, there is no path. Wow. If no current distance, return this distance. Okay. Apparently it's 522, so let's try that out. Bibbidi bobbidi boop. We did it. Decline the banks. I'm not trying to make sense of the de-obfuscated code. What are you talking about? Just finished decompiling my bank's mobile app. That's pretty dope, man. Which bank you got? Well, I just finished up our nice little advent of code day 2. That was pretty fun. Pretty easy. Nothing crazy. Blue Mavex. What you got going on? Cool, let's take a look at leaderboard. Our NIM's up there. Always proud of my boy. Day 12, NIM. Number 15. That's sick. Day 12. How long did it take them? It took them 5 minutes to do this. I spent a good. How long has it been? Day 12. It's been an hour. It took us an hour. I mean, I think every mobile app has some API keys in there. They need to talk to the backend. Well, that's the stream. We did it.